We're now going to discuss how we would write characters and strings when we're using binary I/O. Well, first off, remember that in Java, characters are actually Unicode characters, so that means they're going to consist of 16-bit quantities, which means 2 bytes. If then you output using the write char method, what's going to happen is you're going to output a Unicode character consisting of 2 bytes to the output stream, and that pair of bytes will wind up in the file. Alternatively, if you were to do a write chars, that's plural with an S, then it would be expected that instead of a single a single char argument, you would instead provide a string of characters. And in that case, what would happen is each of those characters in turn, one at a time in order, would be written out to the binary file as a pair of bytes in every case. If you were to pass that same string as an argument to the write bytes method, then instead what would happen is you would get the lower byte only of the Unicode character in each case for each character in the string. The high byte, which may or may not be 0, would simply be discarded. Now in the case of regular ASCII characters, the upper byte would in fact be 0, and it wouldn't make any difference in terms of what information you actually had there, because when you threw away that 0, you would still have a proper ASCII character, since the ASCII code is technically only a 7-byte code, but all 8 bits of each ASCII code would be written in that case. That makes this approach a perfectly suitable method for strings that only contain ASCII characters, as opposed to Unicode characters. Now you'll notice there was a read and write UTF method. This acronym UTF stands for Unicode Transformation Format. On the slide you see it here described as Unicode Text Format, but officially it is Unicode Transformation Format. In any case, it's an ingenious encoding scheme that allows you to use the appropriate number of bytes that you need, so that when the characters being represented are simple ASCII characters, that is, they are 7-bit codes that only require an 8-bit byte to be stored, then that's how many bytes they will take. However, if they are other Unicode elements which are larger and require more bytes, then they will use additional bytes as required. That's a very handy thing, because then if your strings consist solely of ASCII characters, they're going to consume only 1 byte each, whereas if they occasionally have a symbol that's not in the regular ASCII character set, let's say for example the euro symbol would be a good example, then at that case you will use an appropriate number of bytes to represent that, and then you can fall back onto the shorter representation for additional characters in the string that might be fine with just ASCII representation. In one of our demos, we'll take a look at this in a little bit more detail. This idea is described further on this slide, so you see that most of the time you only need ASCII characters, so it would be nice to have a system that allowed simple 8-bit representations, whereas at the same time, when more bits were required, it could use more bits as required. And you'll see how that encoding scheme works. You'll notice at the bottom of the slide it says ASCII values less than 0x7f. Remember, that's a hexadecimal constant, and 7f in binary at 8 bits would be 0, 1, 1, 1, 1, 1, 1, 1. In other words, the most significant bit is always a 0. That is consistent in other bytes that are used in this representation. And what we'll do in our demo is we'll actually throw in a euro symbol so you can see how that differs from other characters in the string that do not require so many bytes. The data stream objects and classes that do the filtering that we're talking about are effectively wrappers that wrap existing input-output streams to do that filtering. In the code at the top of the slide, we see how we would set this up for input and for output. So in the case of input, you would say data input stream, and then as an argument, input stream in stream. In other words, you're creating an object of class input stream as a parameter to the constructor of data input stream. And similarly with output, it's the same kind of story that you see there in that second line of code. The statements that you see at the bottom of the slide show you how to create these streams. The first statement provides an input stream for file in.dat and the second for out.dat.